Hello everyone, this is one of the most basic problems of statics. This will be our first learning question for vector addition. So let's just get into it. First of all, we need to define our directions. And for that, we will first of all just define directions here very quickly. That is one positive direction on each rectangular side. So basically the main thing to know to solve this question is how to divide a force into its components. And basically here you require the knowledge of the triangular identities, which is cosine and sine and tangent of theta. And if you know how to use those, then you can definitely do this question. So let's find the y components of both of these forces first, and let's add them together. So for the first F2, its y component is going to be for F2, its y component is going to be 150 cos of 10 degrees. So basically cos gives you the component which is closest to the force, and that is this direction right here. And the y component of the force F1 is going to be 100 sine of 15. And once you add both of these, what you get is 173.6 newtons. And since this number is positive, that means that the direction of the resultant y component is going to be in the in the positive y direction. Let's do the x components now. The x component for force F2 is going to be 150 sine of 10 degrees plus 100 cos of 15 degrees. And what you get is 122.6 newtons. And since this is positive 2, that means the force is going to be in the positive x direction. To add these two forces, what we need to do is know the right triangular identity, which is, if this is our right triangle, and this is our hypotenuse, let's call it R, and this is F1 and F2, or maybe A and B, then R squared equals to A squared plus B squared, and so R equals to under root A squared plus B squared. So the resultant R for these two forces is going to be under root 173.6 whole squared plus 122.6 whole squared. And the answer that we get is 212.5 newtons. Now we need to find the angle. To find the angle, what we need to do basically is draw the triangle once more. Okay, so the triangle, so we found the resultant, which is 212.5 newtons, and this resultant is basically composed of two forces that we divided into their y and x components, and these components were, let me look at the numbers. These components are 173.6 newtons in the y direction and 122.6 in the positive x direction. So to find the angle theta, which is basically this angle right here, what we need to do is know the triangular identity tangent of theta, and the tangent of theta is 173.6. Tangent of theta is basically opposite side over the adjacent side. So 173.6 divided by 122.6. Once you solve this on your calculators, you'll get theta equals to you'll get theta equals to 54.8 degrees from the positive x-axis. Since this is the positive x-axis, this is the positive y-axis, so we are calculating theta from the positive x-axis. So this is how you split forces into their components, and then you resolve for the resultant force and how you find the angle. So very basic stuff, just requires a little bit of practice.